We are going to solve a Leetcode question which is called as concatenation of consecutive binary numbers. In this question, you are given integer n. You need to return decimal value of binary string formed by concatenating the binary representation from 1 to n. In order to get this value within the range that is required, it's int. So we need to use mod of 10 to the power 9 plus 7 that will ensure that the value that we are calculating is within the ranges of integer valid limits. Let us understand with a simple basic example, which is n equals to 3. According to question, we need to iterate from 1 to 3, and for each iteration we need to find binary representation of that value. For 1 we will have 1, for 2 we will have 1 0, for 3 we will have 1 1. After finding binary representation of each value from 1 to n, we need to concatenate all the values. Once we concatenate all the values, we need to convert back this value to decimal value, which will be equals to 27. This is what we want to do. This is the solution for this example. Let us now understand what will be the nice solution for this. Nice solution will be simply iterating from 1 to n, where you're going to find binary representation of each number. You're going to take a string. After each iteration, you are going to append the binary representation of that number to the string. Once the iteration is done, you are going to convert that binary string to decimal in order to get this answer. That will be a great thing, but when you see the constraint, which is n can be less than equals to 10 to the power 5, which gives a hint that big of n square solution might give you a TLE. So how else you can solve this question? There is a trick in bit manipulation that will help you to do this in big of n time solution. Let us now understand what is that solution. Before going to that solution, one thing you need to know is that you need to know a formula which is log 2 of any number. When you find log base 2 of 2, you will get value as 1. And when you see the binary representation of 2, you will get 1 0, which is represented in a zero base indexing manner. If you're getting 1 here, and when you try to plot it here, 0 will be on the 0th index and 1 will be on the first index when we traverse from right to left, because MSB is always on the leftmost side. This is how we are going to get how many bits are required in order to represent a number. Let us now understand how we are going to implement this. What we are going to do is that we are going to simply iterate from 1 to n, and for each iteration we are going to left shift value of current value by all the bits that are required to accommodate the current value. What I mean from this is let's take an example. We are going to represent n equals to 3. For 1, for current iteration, binary string is 0 0. How many bits are required in order to represent 1? It's only 1. So log base of this will be 0. When we do 1, we will have 1, right? 1 should be added in order to get how many bits are representing this, because it is going to give you the MSB, and by adding 1 you will get the actual number of bits. So only 1 bit is required. When we shift 0 to 1, we will get this value. And when we add 1 to this, you will get 0 1 as a representation after first iteration. In the second iteration, value will be 2. 2 is represented as 1 0. When you find log base 2 of 2, you will get 1 plus 1 will give you 2, which means that 2 bits are required in order to represent 2. Now, currently we have binary string as 1 0. When we do left shift by 2, we will get this as a binary string. When we add binary representation of 2, which is 1 0, we will get 0 1 1 0. This is what we are going to get after second iteration. The third iteration is 3. 3 is represented as 1 1. Log base 2 of 3 will give you 1, and when you add 1 you will get 2, which means that 2 bits are required in order to represent 3 in binary. Currently we have binary string as 10110, sorry, and when we do like left shift by 3, left shift by 2, we will get 1011000. And now we are going to simply add binary representation of 3 in this solution. So now we will get 011011. When we see this is the required answer, which is 27. Let us now understand how we are going to implement this. I am simply iterating from 2 to n, and for each step we are finding the most significant bit plus 1, which is going to give us the bit count, how many bits are required in order to represent a binary number. When we get this, we are left shifting the current value by that much bits, and we are simply modding this value in order to keep the value within the integer range. After this step, we are going to add the current value, which we did it here. Current value. Once we do that, we need to again mod this value to ensure that after adding a certain value, we need to ensure that this also lies between the integer limit. Once this iteration is completed, for example, in case of n equals to 3, we will have 3 iteration. Once it is done, we are simply going to return the answer. Let us now run the code. As you can see, our solution is accepted.